So I appreciate you all for staying around and hanging out with me. My name is Steve Phelps. This session is the What If Not Completing the Square. And I am an instructional technology coach and a mathematics coach at the Hamilton County Educational Service Center here in Cincinnati, Ohio. You can find me on Twitter at MathTechCoach. I think they have a Twitter handle for me and the GeoGebra things that might be a little outdated, but that's okay. But hit me up at MathTechCoach if you have any questions. And I should have put my email in there as well, but Twitter works just as well. And so the two tools that we're going to use today, is
excuse me, Steve. Can we share this presentation with in the chat? Do you think?
Yes, you know something, this is just a PDF file. I will,
okay.
And this is all there is. It's just these two slides.
Okay.
So I will, yeah. So there's nothing else as far as how slides
no
go.
problem. That's okay.
All there is.
That's okay.
Yeah. So the two tools that we're going to use today, the two tools that we will use, I'm going to use Mathagon. And the only reason I'm using Mathagon is to take advantage of their algebra tile tools. It's just so easy to use, and it's going to work perfectly for what we do. So if you would like to tinker around with their algebra tile tools, go to mathagon.org and then click on the polypad. And then I'm going to use the classic GeoGebra Classic and to build kind of some of the graphing things that we're going to look at today. And again, so this is not, you're probably not going to learn anything new about GeoGebra, and but you might learn something new about completing the square and what if not. Now, so this book, The Art of Problem Solving by Brown and Walter, this book was really kind of like there's like a handful of books that just really kind of impacted my teaching. This was one of them. And the idea is that if you have something in math that you'd like your kids to do something with, but you want to come up with a really good question, change one of the attributes and ask about, like, if you change this thing, what could it be then? And so I kind of approached this same idea with completing the square. And so I was at so I'm in Mathagon now. This is Mathagon. And I went to the polypad in the upper kind of a menu bar. And then what I did is on the left-hand side is where the different tools are. And I went down to the algebra tools. And so my friend, this was a long time ago. This was probably 10 years. I was at a T-Cube conference. And so my friend was doing some things with algebra tiles. And he was really talking about completing the square. And he got to something like this. And he made an offhanded comment about that when the linear coefficient, you have your ax squared plus bx plus c, when that linear coefficient, when the b is odd, I could put that in. Yes, I could put that a Mathagon link in the GeoGebra lesson. So when there's only an odd number of x bars, the completing the square model breaks down. And I kind of thought about it for a second. I'm going, well, wait a minute. Why does that have to be? Why is that the case? So I started thinking about it. I go, I wonder what would happen. I wonder what would happen if instead of like splitting up the green bars, those x bars, and distributing them on either side of the x squared, what if we added things to this algebra tile? Like, what if we added things to this to complete the square, if you will? So let me select all this. This is my starting. This is going to be my starting piece, and I'm just going to change the color to make it like a light gray. That's certainly not a light gray. Let me try that again. So I'll make it a light gray because those are the pieces we started out with. But I mean, it is possible that I could add a single X block and I could add 3 unit blocks and I could complete the square. kind of like a new square, if you will. So take a gander at this, and in the chat, if you would like to do this. So one way for me to complete the square is to add an X block and 3 unit blocks, or in other words, I could add an X plus 3. So in the chat, that's what I did to, that's what I added to complete the square. If you'd like to throw in a couple other options in the chat that you could also use to complete the square, throw those in the chat and we'll look at them. And Victoria asked a question, how did I turn that gray again? So I kind of clicked and held my mouse and selected everything that I wanted to change the color of, or I could actually hold the shift key down. I can click on the objects that I want to change. I probably picked up that orange object by mistake, and then in the bottom corner I can change the color. So let me go over to GeoGebra now, and let me throw in, I'm just going to graph that original function. So that original function was x squared plus 3x plus 1. And I have the sneaky suspicion that I'm going to need a slider here in just a little bit. So I'm going to create a slider. That slider is going to be called n. And I just really enjoy using the slider command because I'm just geeky like that. So I'm going to go n equals slider. And I want my minimum value to go from, say, -20 and my maximum value to go to 20. And for right now, I'll have my slider go in increments of 1. And what I'm interested in is, like, when I saw this on the polypad, okay, I can add an x plus 3, and that completes the square. And so the first thing that went through my mind is, what if I graphed x plus 3? I wonder what would happen. So I graphed my original function that I started with, and then I'm going to graph x plus 3. And that didn't do much. That did not do much for me. I don't see any patterns. Nothing seems to be sticking out there. That was really, almost seems like there's nothing to do, but there are a lot of other things that I could graph here. So for example, it is possible that I could also have added 3x, and I would have added 8 more unit cubes at the top. So I could have added 3x plus 8 to have completed that square. So I could have graphed 3x plus 8, and I could have completed that square. I could also have added 5x plus 16, and I could have completed that square. So I'm starting to get these lines that have a kind of a pleasing shape. Maybe it's good. It's kind of starting out to be a it's starting out to be maybe an envelope, but I'm really not sure. So what I am going to do is, in general, I could come up with a formula based on the slider n, and I could kind of capture like an infinite family of things that I could add to this diagram here. So I could add many other x bars and unit cubes. I could also take things away. I could have taken away 3x blocks and 1 and completed the square. So what other, correct, yes. Correct, I could have done that. So in other words, you're taking away an x block. So and that's certainly a legal move. So in general, what I could do is I could go, I think it would be 2n minus the blocks I have times x plus, and then I have this n squared minus 1 because there was already 1 block there. And that's this purple line. That's this purple line here. And so I'm going to actually trace this purple line. And as I drag my slider around, it ends up that these are all the different things that I could add. So It's not 16 because there was already a unit square in my collection of algebra tiles. So the reason it would be 16, but I've already got one in there, so I'm going to take one away and make it 15, if that makes sense. Great, that is a great question. Great question. Which is why in my formula here, in this formula, let me see if I can kind of oh, I did not mean to do that. That was a teacher technique when I did that. Let me see if I can zoom in a little bit. Nope, can't zoom in there. Let me try that here. So on the left-hand side, the 2n, because there's an algebra tile on each side, and then there's an n squared minus 1 because that I'm going to add n squared units, but I've already got one there that I'm not going to take into account. Yes, I have. Maybe I'm misunderstanding your question. I do have 16, but there's already one there. I'm interested in what I can add on to complete the square. So I would add on 15 units, not 16, because one of them already exists. Oh, did I write it? Oh, yeah, I was a teacher. Oh, that's a teacher technique. So you're paying attention. Nicely done. Thank you. But my formula is correct. So that should be, I see what you're saying. Yes, teacher techniques, if someone is paying attention. So here again is my, there's my envelope. So it kind of appears like, this seems weird. It kind of appears that if I were to flip all of these things upside down, like all of those purple lines, if I were to flip them all upside down, it appears that they would all be, maybe, I wonder if they would be tangent to that original parabola that we started with. So what I'm going to do is I'm just going to take this q of x function and let me jiggle the screen around, and I'm going to graph negative q of x. And now let's trace this function. Oh man, GeoGebra's everywhere. And let me drag this puppy around. And sure enough, it appears that all of those things that the opposite of everything that I could add is tangent to the thing we started with. So let me hold on. Let me take a deep breath. Let me change the color of this puppy. I'd like that to be a slightly different color. Let me make that like an orange. And then let me animate this. So everything that all of these lines that are tangent to the parabola, all of those orange lines are things that are the opposite of what I added to complete the square. So whatever I added to complete the square, if I graph the opposite, the negative of that, the negation of that, that's going to produce a line that is tangent to the original parabola. Oh, yes. So again, this is one of those things that I kind of mess with. Let me pause this for just a moment. And let me, what I would really be interested in is I'm going to shake this off and I'm going to untrace my line. I'm kind of interested in what the original, like what the completed square would be. So for a given Q or a given orange line, what would the completed square be? So my original function was f of x. So I think I could get away with going f of x plus q of x. And so now let's watch these things dance back and forth a little bit. So the orange is the opposite of what I added. Exactly. And this red graph is the square that has the new things in it. And so it appears that where is the vertex of that red parabola? Like that vertex, where does it appear to be? And it kind of appears to be like directly above or below the point of contact between the orange line and the red line. Like what the heck is going on here? This is This is absolutely nuts. This is absolutely nuts. So let's see. Got some questions, comments? Perfect. I hope I haven't messed anything up other than the 15. I'm sorry I misunderstood that question. I feel so bad about that now. That's because I'm hungry. It is lunchtime. Anyway, so let's explore. Let's do a little bit. Let's do some other things with this. So this idea of adding things on and graphing the opposites, and those opposites seem to be tangent to our original parabola or original kind of a graph, and it seems to be tangent kind of directly above where the vertex of the completed square is. That's, I mean, there's a lot of stuff going on. What I'm wondering is if I wonder if it would work for other quadratic things, like a circle, for example. So I wonder if it would work for a circle. So let me delete some things here just for kicks. Let me go ahead and select everything. I wonder if it'll let me delete it. Oh, perfect. BJ, nicely done, man. Nicely done. So I'm going to graph x squared plus y squared, and we'll just make a unit circle here. We'll just make a unit circle, and I'll zoom in a little bit on this puppy. We'll see what happens. I have no idea what's going to happen. I do know one thing, though. I think I will need a slider again. And so if you've been paying attention at home, n equals, I'll make my slider go from -20 to +20, and I'll set my increment to be 0.1 instead of an integer value. And I'll stay right here. And let's go over here to the polypad again. And let me, oh, I haven't signed in yet. That's, of course I have not signed in. So let me select everything and let's see if I can trash some things. And then let me see if I can erase this 8 that I drew there. So if I am going to do a circle in algebra tiles, what I would like to do is to represent this circle equation, x squared plus y squared equals 1. What I would like to do is to rewrite this with all of that stuff on the left-hand side of my equation. So what I would really like to do is, instead of writing it like this, I would like to write it like x squared plus y squared minus 1 equals 0. So when you're dealing with general quadratics, from an algebra tile perspective, I want to rewrite it so it's something equal to 0. And so what I can do then is go to my polypad, and I can plop an x squared out there into my workspace. I can plop a y squared out there into my workspace, and then I can plop a -1. But let me delete this. Let me delete that one. I'll show you this one. I'm going to actually drag a +1, and then I'm going to realize my mistake. And I can, while it's selected, it allows me to negate it. And so this collection of algebra tiles would represent the circle, a unit circle centered at the origin of radius 1. And so what can I add? What can I add to this collection to turn it into a square? Well, to start with, I think I'll just kind of turn it into a basic square using those pieces. And then along the outside edge, I could place an X there, and I can place a Y there, and I can place a Y over yonder, and an X over yonder still. And now this -1 is will cause trouble. I need to add 1. Now this, when I add 1, these two things cancel each other out. Look, wait a minute. Did you see what happened there? When I drag this one on top of that one, they turn into 0. Ooh, mathagon. And so really what I need is I'm going to have to add 2 x squared. So I'm adding our 2 unit blocks. So there's 2 unit blocks that I've added, and that negates the 1, but it does complete my square. It does complete my square. So let's graph. I know in a parabola we would graph the opposites, but let's graph what we added, since everything's on one side of the equal sign and it's equal to 0. If I graph the opposite, it's not going to change anything. So I'm going to graph 2 xy's, 2 x's, 2 y's, and 2. I don't know what's going to happen. I can't wait to see what happens here. I hope it works. So I'm going to graph 2xy plus 2 x's plus 2y's plus 2 equals 0. What? What? Wait a minute. What is going on there? So let's go back here. I could also add 4 x's. So I could put another x out here. I could put another x out there. I could put a y over yonder. I could put a y up here. And then now this one here, those two kind of cancel each other out. But so I could add 5 units. I need to add 5 units because the 1 unit will cancel out the negative x. So I would add 5 unit squares. So let's go back. Let's go back. And so let's change this to change that to a 4. Change that to a 4. I don't know what's going to happen. Change that to a 5. I don't know if this is going to work or not. This may not work. Oh, what the, oh, yes, I think let's try something different. Let's do this. Instead of 4x, I'm going to put in 2 times n. That's n is my slider. And instead of 4n, or instead of 4, I'm going to put in 2 times n because n is my slider. And instead of 5, I'm going to put in n squared plus 1. I don't know what's going to happen here. I can't wait to see what happens. Oh my gosh. Let's change that color a little bit. Ooh, that might look pretty. Let's see. I don't know what's going to happen. Let me trace this. I have no idea. I hope this works out. I'm really kind of nervous. Let me thin it up a little bit too. Let me thin this up a little bit because I have a feeling, just in case it goes wrong, you won't be able to see it very well. That's what I'm hoping. And let me hide the grid. Okay, so let's animate this slider. I have no idea what's going to happen. So when you complete the square for a circle, you get all of these different hyperbolas. Some of them are tangent to the circle, but as I animate that, kind of that coefficient there, the 2n and the 2n, as I animate that, well, I got time. Kaja, I need to leave 5 minutes. Is that correct? 5 minutes for the first session, or for the next session, which starts at a quarter after, I believe. So I think I'm doing okay. I think I'm doing okay.
You're doing very okay.
Whoa.
Everybody's excited. Don't slow down. Don't speed up. You still have 2 minutes.
So this is a circle. This was a circle. So let me go back to the polypad. So I don't know. This may or may not work out, man. It's one of those things. I like to try things just on. This is like a Edwards thing on the fly. I like to try things on the fly. So let's see what happens. Let's see. So what if I did instead of an x squared, what if I did 2x squared and a y squared? And so this would be an ellipse. This would be an ellipse that is probably going to be taller than it is wider. And let's see if we can kind of figure out what things we would need to add. So in order to complete the square, because we can't complete rectangles, I know I did try that. That does not work. I would need to add 2 more x squareds down here to the bottom, but I don't need to add any more y squareds, though I could. That would be interesting. And so this now requires 4 y pieces, and I do believe I think I forgot to include my -1 up here in the upper right corner when I originally set up my equation. And so I think everything is going to be quite similar to what we did before. We would end up adding like 4 xy's. We'd add 2x squareds, 4 xy's, 2 y's, and then I think everything's going to stay the same, like the n squared plus 1. So let's go back here and give this a try. So let's change our equation. There's this equation. Oh my God, I stopped. Let me jiggle. Perfect. So let me put in a 2x squared there. Don't know what's going to happen. Oh, it did work as intended. Fantastic, fantastic. And so now let me go to my my next equation. Let me click down here. I added 2x squareds, if I recall. If I recall correctly, I added 2x squareds. And then I had to add 4xy's. And then I also added 4 x's. So I kind of scrub the background, Karen. So if I click in a white space and I shake it around a little bit, it's kind of like the scrub tool in Graspable Math that clears the trace out. I likewise could have zoomed in or out as well if I wanted to, but whenever you grab that background and change the background's location, it's going to clear the trace in a graph app. And then, but everything else in this next equation is going to stay the same. At least yeah, because everything else is going to be, I don't know what's going to happen. I'm excited. I hope this works out. Let's animate this slider. Man, if this works, this is going to be awesome. Let's see what happens. Oh, wait a minute. But like those hyperbolas, the hyperbolas with a circle seem to be rectangular hyperbolas. I don't know if these are rectangular hyperbolas or not. Oh man, look at this. So it even works. It even works when you're dealing with an ellipse. Oh man. I just like that little spot. I like that little when it kind of gets closer. Let me keep jiggling that puppy around a little bit. Let me jiggle it, and let's watch it go. Bink. And kind of just bounces right around. So I guess the only other question, let me stop this. And I've got time to I'll do one more. Since we've done a parabola and we've done a circle and we've done an ellipse, I think it's probably appropriate. And yeah, this is perfect. I think it's probably appropriate. Oh my goodness gracious, look at all these tiles. Let me select everything and delete. Oh, I missed. I've got so many Zoom windows open. I think that's my problem, kids. I've got Zoom windows on top of Zoom windows. You think I'd get better at Zoom windows after Zooming for 2 years, but that's not the case. So let's do a hyperbola. So a hyperbola is going to be I'll make it a positive x squared, but to turn it into a hyperbola, I would use no, that was a teacher technique. That's not what I wanted to do. I wanted to grab a y squared. I would grab a negative y squared. And I'm going to say that's going to be equal to 1. So x squared minus y squared plus 1. So let's go back here and fix this equation here. I'll delete that equation out. And I will go x squared minus y squared. And that's going to equal 1. Oh, so I do got to turn that into a -1 then, because if I recall how I did this, I have to write everything on the other side. I guess I could have written it as yeah, so I got to write everything like that. So I need to go back to my polypad and I need to negate that 1. So here's what I would like to do. So when I'm dealing with negative algebra tiles are tricky. So what I would like to do is I would like to add something to cancel out the negative algebra tiles and then kind of fill in the empty space, if you will. So I'm going to add a positive x squared. That will cancel out those two puppies. But I'll put in another x squared to kind of a y squared to take its place. So those two kind of go away. I will also add a unit block to cancel out that puppy. I could put another one in to take its place, which means I would have a positive xy there and a positive xy there. And I could add a whole bunch of different x and y blocks up there, an x block and a y block there. And I remember, so what I actually added to make this work, I added 2 xy blocks, 2 y squared blocks, 2 unit blocks, 2 x blocks, 2 y blocks. So let's go back and see who knows what's going to happen. You've probably heard that before, right? Have you heard that before? Who knows what's going to happen? So let's see. So if I did this correctly, I added 2 y squared blocks. And then I added 2 xy blocks. Nope, I can't put them side by side there. 2 xy blocks. And then I added 2 x blocks. And then I added 2 y blocks. And then I added 2 unit blocks. A lot of 2's there, and that's going to be equal to 0. And what the, look at this. I don't know what's happening. Is that a hyperbola tangent to another hyperbola? Oh my goodness gracious. Let's select this puppy and change its color so we can kind of really, oh, let's see what happens. Now let's include our slider. So our slider could control the number of y squared blocks, but we'd have to do some things. Well, I'll leave something for you guys to investigate, but I'm going to put right inside that 2. I'll make that an n. And oh no, I don't want to don't want to change x, y blocks. I want to change the x blocks. Make that an n there. I'll make that an n there. Oh, let me go back. And then this was an n squared plus 1. And let's see what happens. Oh my goodness. And let's animate. So we have hyperbolas tangent to other hyperbolas. Completing the square, taking the things for conics, the parabola is kind of weird to explain why it works the way it does. I'm just graphing the things I add for these other conics because it's everything's written on one side. I think if I did that for parabolas, I could probably get away with it. I haven't thought more about that. Let me pause this. Let me jiggle. Let me go to the settings and see if I can make the style of that line, make that line a little bit thinner, and see if we can see it a little bit more. So this is a oh, there it goes. Hyperbolas, tangent to hyperbolas. So this idea of completing the square, it works for algebra cubes. So if you wanted to go into like 3 dimensions and do things with cubic equations, you can do that. I'm just staying down here in the plane and taking advantage of the different tiles in the polypad to kind of make things work. But it is a lot of fun. It's just a little tinkering. This all started, kids. This all started. Wow. Back at a T-Cube conference like 10, 12 years ago. So yeah, 3D printing something behind me. I'm just making sure my filament's not being stuck. So that's all I got, kids. What question you guys have, man? I guess you'll have to drop them in the chat. Oh, I appreciate it.
Wonderful, Stephen. Wonderful. It's as usual, very inspiring. Keeping on the edge of the seats.
Oh, like that.
You always make from mathematics. You make it like we are watching a horror film or something.
I will stop my sharing. So
Okay,
yeah, this
so
is
much.
just something I like to do, but if I would have never asked the question, like, what would happen if I did this? Like, why don't I graph this and see what happens and then try with other things? So it's got to start somewhere.
Yeah, it's wonderful with this GeoGebra. Yes, without GeoGebra, this is impossible to experience.
Yeah, so I appreciate it. Appreciate it, kids. I appreciate
very impressed.
You guys know how to reach out to me if you guys want. If you guys need to, I'll put this in the chat. You know, I'm at Math Tech Coach on Twitter.
I am trying to update. I will try to update your profile for the conference also. If you put it in the chat. Oh, this is oh my gosh, you lost me.
It's okay. So yeah, so I'm at you can shoot me an email or hit me up at Math Tech Coach. So anyway, appreciate you guys coming today.
Thank you so much. Thank you, Stephen.
Have a great rest of the conference.
Thank you very much. Thank you. You have to finish now the webinar, and we will be taken to the lobby and for the next meeting.
We'll
Thank
do
you
that.
so much.
Thank you.
Appreciate it.